Okay, so this will be, oh, I forgot to change the section. This will be the prep video for section 2.3 on continuity. And we'll also do a little bit with difference quotients that will set us up well for section 2.4 when we introduce the limit definition of a derivative. Okay, so I learned my lesson, got the graph up already this time. So let's talk about what continuity is. Continuity is really any function that has no gaps, jumps, breaks. It means that you can draw the function without lifting your pencil. So anything that goes up to infinity and stops and comes back down, there's no point there, so that's not continuous. Anything that's got a hole, you'd have to lift your pencil technically to go across the hole and keep going. So we know what continuity is. I mean, it's smooth. It doesn't, well, I'll take that back. It doesn't have to be smooth. It just has to have no breaks and jumps, so that's continuous. So we kind of know what it is intuitively. So let's define it in terms of math. So a function is continuous if three things. The two-sided limit exists. I say continuous at a point. Let's just say continuous. If the two-sided limits exist, if the function itself is defined at that point, and if the limit and the function are the same thing. So the limit equals the function value. So shorthand, you could just write the limit as x approaches c of f of x is equal to f of c. The two-sided limit exists and is equal to the value of the function which also exists. Okay, so let's take a look at this and see where it's continuous and where it's not. Let's first identify where it's not continuous, and then we'll write all of the intervals where it is continuous. So let's just start walking along. So here, this looks like it's going to, kind of continue on for forever. So that seems okay. We get to this point at -4, and we have clearly a problem. The two-sided limit does not exist. It is coming from, it's heading towards 2 from this direction and 3 from that direction. There's a big jump. So there's a discontinuity at x equals -4. Okay, let's keep going, going. A hole in the graph, automatically a discontinuity. So that lines up with x equals -2. Come across. This has two problems. There is no defined point at x equals 1, and the two-sided limit doesn't exist. So we have two problems here. So let's actually write what those are. So we have a gap for this one. Maybe I'll say a jump. So that jump. We have a hole in the graph here. We have a hole and a jump here. And then as we're moving along here to x equals 3, we see that the problem, it's the two-sided limit exists and the point exists. So those parts are okay, but they're not the same. So at x equals 3, the problem is that the limit does not equal the function value. Okay, so those are all the places where it's not continuous. So continuity is pretty intuitive. So let's, as a last point, list where it is continuous. So it is continuous. It is continuous up until 4. So from -infinity, -4, to -4. At -4 we have a problem, but right after that we're okay. So from -4 to -2. And there's more. And then from -2 all the way to x equals 1. And then from 1 to 3, where we have to stop again because it's discontinuous, and then from 3 on. So 1 to 3, and then lastly 3 to infinity. So clearly it's a little bit easier to list the discontinuities in this case than it is to list the actual continuous intervals. But so continuity is pretty intuitive. Okay, so now let's look at difference quotients. You may have seen these in pre-calculus. We're basically using composite functions. And I'm not going to get into what we're going to do with them yet. I just want to make sure that you guys can put them together. Okay, so this is what we're aiming to form. This is called the difference quotient. Sometimes I call it DQ, just for short. It is the function evaluated at x plus h minus the function evaluated just at x, the way it's normally written, all divided by h. And we'll get into that in class why we're doing this, but for now I just want to make sure that you can form this fraction. So we're going to look at it in multiple steps. So let's start with an example. F of x equals x squared minus x. So the first thing we're going to do is we're going to kind of do this in parts. We're going to form this part, and then the subtraction, and then the division. Once you get good at it, feel free to just do it all in one step. I mean, that's where we should be aiming for, but in the beginning, we'll kind of break it apart. So the important piece is this. This is where most people make their mistake. This is an input. It goes in everywhere I used to have an x. I can't just take this and just tack on plus h at the end. That's not how that works. I've changed the input. So that means everywhere I had an x before, I now need to put an x plus h. So I used to have an x squared, so now I have an x plus h squared. Here I used to have an x, so now I have an x minus x plus h. Keep your parentheses. I recommend doing this step all with parentheses. When you have negative signs or square terms or multiplying by a constant, you're going to want to keep all of that straight. So please use your parentheses. Okay, so now we have this piece and we want to subtract. I'm going to take this off for a minute and make it a little more clear. We have this piece and now we want to subtract this piece. You can either do it vertically or horizontally. Before we do that, let's go ahead and multiply out. This is a case where you want to multiply out so that you can recollect like terms. So here we'll have x squared. This is a perfect square, so there is a pattern to that. 2xh plus h squared. If you don't know that pattern and you want to go ahead and write it out separately like that, then you'll very quickly find that you get right back to this. So the pattern is you square each of the terms, and then the middle term is these multiplied times 2. Okay, and then we have this one. Let's go ahead and deal with the parentheses at the same time. Okay, so this is our f of x plus h. So now the question, now you can we're going to form this bit next. So you can either do it horizontally or vertically, either one is fine. Let's just go ahead and do it vertically for now. So we're going to subtract off, what is f of x? And I'm going to line things up. I'm going to subtract off, you know what? I think we're used to doing that with numbers, but when it comes to variables, I think we're used to writing it out horizontally. So let's do that. So f of x plus h minus f of x is going to be equal to, now I got to rewrite it all. So x squared plus 2xh plus h squared minus x minus h minus x squared minus x. Keep your parentheses. And anytime you're subtracting anything, start with parentheses. Okay, now we can rewrite this next step. And again, as you get good at this, you won't have to write out so many steps, but until you do, until you are reliable, oops, that's a minus, please write out the steps. Now we can start collecting like terms. X squared minus x squared, they cancel. Negative x plus x, they cancel. So when we're collecting like terms, we're going to get some canceling. You should expect that. You should expect, once you've done your canceling, but you have to make sure it really works, that eventually you'll end up with things that really just have h's in them. So this is this part, f of x plus h minus f of x, and now we need to take the entirety of that and divide by h. So we'll take this, 2xh plus h squared minus h all over h. We need to do a little bit more cleaning up. Do not cancel the h's. Remember, you can only cancel multiplied terms. That's not multiplied, that's subtracted. So, there are two ways you can do this. One way is to go ahead, you can see that there's an h in everything in the top. So let's go ahead and factor out the h. 2x plus h minus 1. Remember, when you factoring out is like dividing by. So h divided by h is 1, not 0. Divided by h. Now we have multiplied factors. So now those cancel. So in the end, finally, our difference quotient is 2x plus h minus 1. And that's something that we're going to work with, and that will turn out to be pretty cool. So let's just review. You're trying to form this fraction. You're given this. You need to start with finding f of x plus h first. X plus h is an input, so it goes in everywhere you used to have an x. You cannot just tack an h on the end. That doesn't work. Once you've plugged it in, multiply it out, deal with your parentheses. Now you need to form the subtraction. Go ahead and subtract that. You can go directly to this step, no problem, if you want to. Just be careful. After you multiply everything out, deal with all the parentheses, collect up all the like terms, you should end up with something that really just every term has an h in it. That's what you should expect. Don't force it. Do the math, make sure it works right. Then divide by h. You can factor out an h. Or if you see that there's an h in every single term, you can cancel it out of each term. But it has to be in all the terms. And again, remember, when you factor out or cancel out an h out of an h, you're left with 1, not 0. Okay, that's it.